So in this problem, what we want to do is we want to graph the solution set to this system of equations using a polygon tool and drawing a polygon around the solution region. And we will click to set the corner points of the polygon here on the graph. So this polygon tool down here works by clicking individual points in a polygon to create the sides. And then when you want to close the polygon, just connect the original dot to the last one you just did. And when you click, that region will be shaded for you. This is just an arbitrary polygon region here that I created to show you how to use the tool. So we're going to clear that and then work with this system. So let's notice that the first equation, 2x plus 3y is less than or equal to 12. We can graph that line just to see what it looks like by finding the intercepts. So if x is 0, then y, 3y is equal to 12, y will be 4. So when x is 0, y is equal to 4. So let's draw that first point. Now notice that when y is 0, 2x will be 12, so therefore x will be 6. So when I connect that second line, that second point rather, this gives me a picture of what the top line looks like. 2x plus 3y is equal to 12 looks like this line. And so we know that one side or the other of that line has to be part of my solution set. Now if I look at the second equation, we do the same thing. If x is 0 on this equation, then y will be 8. So with x is 0, y is 8. And then for the second point up here, if y is 0, then x is 4. So when x is 4, y is 0. So there's a second point on the second line. So when you look at this, you'll see that this creates multiple regions. There's this region here in the corner, this one up here, there's this one here, and then there's a big, huge region over here. So we've got 4 potential regions that could be the polygon. But we've only used the first 2 equations so far. We know that x has to be bigger than 0, so it has to be everything over here, and it has to be true that y is bigger than 0, and so that means we're in the first quadrant. Well, great. That we still have 4 regions, so we have to do a little bit of testing, right? So the best way to do this is to look at each of these equations here and pick a point in a region to see if it works. So for example, let's pick the point 10, 10, this point right here, to see if this big region over here is part of the solution set. So if I put 10 into the first equation, 2 times 10 plus 3 times 10 is 50. And this statement would say that 50 is less than 12. Well, that's a false statement. So that means that the point 10, 10 does not satisfy this first equation. And so it has to be over in one of these other regions. Now, this line here, 2x plus 3y is equal to 12, was this line here. So what that tells me is that if 10, 10 cannot be in that solution set, it has to be over here on this side of this line here. So my region has to be over here. So that narrows it down to either this one, or maybe both. It can't be this one because this region is on the wrong side of this first line that we just tested. So now basically what we have is we have to decide if it's this region here or maybe this region here. So let's pick this point, 1, 1, and let's test it in the second equation to see if we get a true statement. If we do, then we know it has to be, the solution set has to be this region here. So if I put 1, 1 here, 2 times 1 is 1, 1 plus 1 is, 2 plus 1 is 3. Is 3 less than or equal to 8? Yes. So this one satisfies the second equation. So we're pretty confident that this is the region that contains this point 1, 1. Now, if we wanted to, we could test a point over here in the second equation. Let's go with 4, 1, just to see if this is part of the solution set. right? So 4, 1 is in that region. Let's test that in the second equation. So 2 times 4 is 8. 8 plus 1 is 9. Is 9 less than 8? No, that's a false statement. So 4, 1 is not going to work for us. And so what we have now is that the, excuse me, the region is going to be this polygon here, where one point is the origin, one point is up here at 4 on the vertical axis, one corner point is over here at 4 on the horizontal axis, and then you have this point right here, which looks like it's 3, 2. Now, we should check that to make sure. Is 3, 2 the point where these two lines intersect? There's a couple ways you could do that. You could solve this system of equations to see if 3, 2 is what you get, or you could just test 3, 2 in both of them to see if it satisfies both equations. So let's put it into the first one. 3 times 2 is 6, plus 3 times y, which is 2, is also 6. 6 plus 6 is definitely equal to 12. It works in the first equation. Now let's check it in the second equation. Does 3, 2 satisfy this equation? 2 times 3 is 6, plus y is 2. 6 plus 2 is equal to 8. So there we have it. The point 3, 2 is a point. So now what we have is our 4 corner points. This one, 3, 2 is one of them. 4 over here is the next one. 0, 0 is the third one. And 0, 4 is the last one. So let's clear it all up, and let's begin to draw our corner points. So let's clear this. We know that 3, 2 was the intersection point, so we can start there. Doesn't matter where we start. We knew that 4, 0 was one of the corner points. We knew that 0, 0 was another corner point. We knew that 0, 4 was a corner point. And we knew that we would have to connect that back to the intersection point 3, 2. So when I click, there is the polygon region that satisfies the solution set to this system of equations. So what we have to keep in mind here is the process is as follows. Determine where the corner points are by drawing the lines that are in the system, potentially identifying points of intersection along each of the two axes, find the point of intersection for equations that are in the system, and then begin to test points to see which ones satisfy the inequalities in the system. And once you're confident that you've got all the corner points correctly identified, then you just connect them with the polygon tool and submit your answer.